With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I hope you all are doing good. So today our question is like this. At 600 degrees Celsius, Kp for the following reaction is 1 atm. We have the Kp for the reaction as 1 atm. So our reaction is X gas converting into Y gas plus Z gas. Okay. So at equilibrium, 50% of X is dissociated. The total pressure of the equilibrium system is P atm. So what is the partial pressure in atm of gases at equilibrium? So we need to give the partial pressure of gases. So our options are 1, 4, 2 and 0.5. Okay. So by this option you can easily identify that partial pressure of each of the following gases will be equal. Okay. So now let us do this question. Okay. So we have reaction like this. We have X gas at equilibrium converting into Y gas plus Z gas, Y gas plus Z gas. Okay. So we have at equilibrium 50% of X is dissociated. So let us take at t equals to 0, initial moles of X is 1. Let us take at t equals to 0, initial moles of X is 1. These are the initial moles, and initially these are 0 because on the start of reaction Y and Z are 0. So at t equals to 0, let us take moles of X as 1. So after equilibrium has reached, that is at t equals to t equilibrium, we have given that at equilibrium 50% of X is dissociated. That means half of the X is dissociated. Half of the X is dissociated. So remaining X will be half, that is 1 minus 1 by 2. This is the remaining X, and Y and Z will be formed like this, 1 by 2 and 1 by 2. Okay. This is how Y and Z will be formed. Okay guys. I hope you guys are understanding it. We have given in the question that half of the X is dissociated. Half of the X means half of 1. Okay. We have given in the question that 50% of initial X is dissociated. 50% of initial X is dissociated. Okay. We have given that 50% of initial X is dissociated. We have initial X as 1. So 50% of 1 will be 1 by 2. That means 1 by 2 is dissociated. So left X will be 1 minus 1 by 2. And if 1 by 2 moles are dissociated, then Y and Z will be formed in the same amount. That is 1 by 2 and 1 by 2, because stoichiometric coefficient of Y and Z are 1. Okay. This is how we write the moles at equilibrium. So the moles will be 1 by 2, 1 by 2 and 1 by 2. These are the moles at equilibrium. Okay. So if number of moles of each of the following gases are equal at equilibrium, as you can see, so mole fraction of each of the following gases will be equal. Okay. So mole fraction of X will be number of moles of X, that is 1 by 2, divided by the total moles, that is 1 by 2 plus 1 by 2 plus 1 by 2, that is 3 by 2. That is 3 by 2. So it will be, mole fraction will be 1 by 3. Mole fraction will be 1 by 3. So it will be equal for each of the following gases. So it will be mole fraction of Y equals to mole fraction of Z. Okay guys, because we have same number of moles, so we will get the same mole fraction. Okay. So, and we know according to Dalton's law of partial pressure of gas X, or we can say partial pressure of gas, will be equals to mole fraction of gas into total pressure, and we have total pressure as P atm, and we have same mole fraction for each of the following gases. Okay, we have total pressure as P atm, and we have same mole fraction for each of the following gases. So partial pressure of each of the following gases will be, what is the mole fraction of each of the following gases? We have 1 by 3 into total pressure, which is P atm. So partial pressure of each of the following gases will be P by 3, and it will be equals to partial pressure of X, it will be equals to partial pressure of Y, and it will be equals to partial pressure of Z. Okay, because we have same mole fraction, so their partial pressure will also be the same, that is P by 3, P by 3, P by 3. Okay, so partial pressure of each of the following gases will be P by 3. Now we have to find the partial pressure of the gases, that is we have to find the P by 3 value. Okay, so we know Kp will be equals to, Kp for this reaction will be concentration. Here we have gaseous form, so we for finding the Kp we have to take the partial pressures. Okay, so finding the Kp we have to take the partial pressure. So Kp will be equals to partial pressure of Y to the power 1 into partial pressure of Z to the power 1. Okay, into partial pressure of Z. Okay, let me write it more correctly guys. Into partial pressure of Z to the power 1, because we have stoichiometric coefficient of Y and Z are 1 respectively. So it will be to the power 1 will be Py into Pz divided by partial pressure of X to the power 1, because we have stoichiometric coefficient of X is 1. So this will be the value of Kp. Okay. So I hope you are understanding it, and we have given Kp value as 1 in the question. We have given the value of Kp in the question as 1 atm. So it will be 1 is equals to Py. What is Py? We have all of these three quantities are same, that is Py3 into Py3 divided by Py3 divided by Py3. So Py3 will be cancelled, and we will get P/3 as equals to 1. So this is the P/3 value, and we have total pressure as P atm. So total pressure will be the 3 atmosphere. Total pressure will be the 3 atmosphere, but we have to find the partial pressure of gases. So partial pressure of gas X, Y, Z is P/3. So it will be equals to Px equals to Py equals to Pz. So partial pressure of gases at equilibrium will be 1 atmosphere. This is in the atmosphere, so it will be 1 atmosphere. So our option first is the correct option for this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.